Welcome to my talk about how to stop hating GFCIs by measuring leakage. I'm sure this has happened to you. You come home and part of your display is out. I usually just try to reset the GFCI, and if that works, I don't do anything else. If it doesn't reset or it keeps tripping later, I will go around and play with the lights to see if I can get them to work. That approach doesn't work very well. About 6 years ago, I decided to do something about it, and I built 2 power distribution boxes. I took a socket dry box, a 4-gang electrical box, 4 GFCIs, and a 2-foot extension cord. Hook them all up, and you have 4 times the GFCIs, so even if it trips, you only lose 1 circuit out of 4. The extension cord to this box will be plugged into a non-GFCI outlet. But even with this, I still had issues I mostly just ignored. Then a few years ago, one of my friends suggested that I should join him in volunteering for the annual Garden Delights display at the Bellevue Botanical Gardens. We use a lot of power, and we use an electrical contractor to put in temporary power for us. They use big boxes that can pull several hundred amps of 3-phase power, and those connect out to small boxes with outlets in them. A typical year, we might have 44 boxes, which means 132 outlets. That first year, I talked with the electrical contractor during installation and asked him whether we would have any issues with the GFCIs, and he said that they did this all the time and never had issues. It takes about 10 to 12 days to do the installation, and it happened to be a dry couple of weeks, and things went well. Then a few days before we were scheduled to open, we got a lot of rain, and half the installation went down. It was then that I found that the guy who had done the power in the past had retired, and he ran the show with boxes that didn't have GFCIs. We spent a few days trying to fix the show, pulling out plants that appeared to be problematic, trying to rewire things, anything that we thought might work. It was not terribly successful, and during that year we just tried our best and limped along. Without any good way to quantify the problem, there were a lot of different theories amongst the volunteers. It was bad extension cords, water getting into outlets, incandescent lights, the point where light strings connected to extension cords, leakage into the steel rods we build our plants on, and of course, magic leakage pixies. And now I need to spend a few minutes talking about GFCIs. We'll start with my toaster connected to a power source. It uses about 7 amps of power, and that means 7 amps flowing into the toaster and 7 amps flowing out. If we put the toaster out in the rain, it's going to get wet, and that gives us the opportunity for leakage between the hot line and the ground. That is bad because that leakage path might involve a human, and it might be enough current to be dangerous. The code standard says the limit is 5 milliamps of leakage, and that much leakage means less current coming back from the device. It is that imbalance in currents that the GFCI is designed to detect. A triggerable switch is put in the 2 conductors and connected to some electronics. A current sensor is put around both conductors. It senses the difference in current between those 2 conductors, and if it's 5 milliamps or greater, the electronics trip the switch and power is interrupted. This is in general a very good thing, but GFCI trips are a significant problem for light displays. As it is not one electric device, it's hundreds of devices. What we needed is some way to measure the leakage current so we could have more information than tripping or not tripping. Given that information, we could make informed decisions. Fluke makes a very nice current leakage meter, the 369FC. And if you know anything about Fluke meters, you probably won't be surprised that it retails for a little over $1,000. Out of my budget. There is, however, a cheaper version that you can find on eBay. Mine is a Victor 140A. But there are others that look the same and have different names. They cost about $100. At this point, you might be saying, I already have a clamp ammeter. How are these different? The difference is in the ability to measure small currents. This Klein meter is pretty good. At the low end, it has a resolution of 1 milliamp. That's probably good enough to use in this application. And if you have a clamp ammeter that goes down to 1 milliamps, start by using that. This Milwaukee meter only has a resolution of 10 milliamps. It won't be useful. The Fluke has a resolution of a microamp, or 1/1000th of a milliamp. The Victor also has that resolution. The flute costs 10 times as much because it's very rugged, is calibrated against a standard, and will likely last pretty much forever. I bought a meter right away and spent one very wet morning walking around and taking measurements of maybe half of our plants. The measurements were all over the place. In this gallery, we see one set of plants leaking 0.04 milliamps and another set leaking 0.9 milliamps. I found one that was more than 2 milliamps, which is a lot. How do we troubleshoot issues with a leakage meter? Since we're measuring the difference in currents, we can just clamp our meter around the extension cord or both wires on the light string, with one caveat I'll talk about later. Here's a scenario to talk about, with 3 strings plugged end to end and then plugged into a GFCI that has been tripping. Our first step is to try to reset the GFCI. If we can get it to reset, that's a good thing. If we can't, we'll need to temporarily unplug the string from the GFCI and plug it into an extension cord that is connected to a non-GFCI outlet. Once you have the circuit back functional, put the meter around the cord at the start of the first string. This will give you a decent idea of the current state. If it's reading more than 2 milliamps, then go to the last string and put the meter there. This will tell you whether the issue is in the last string. If it's not, work your way back. It's this process that will tell you where the issue is. If you start with a decent amount of leakage and it goes away when you're working your way back, it means something you changed fixed things. I do have a golden rule to follow. Disturb your wiring as little as possible during the troubleshooting. Leakage issues are notoriously fickle, and if you start moving things around, there's a decent chance you will break the leakage path and temporarily fix things. This is a common issue in our display. A GFCI will have been tripping, and then somebody played around with things, and I put a meter on it and it reads 0.1 milliamps. Hard to do anything with that. Extension cords are a special case, as it's possible to get leakage between the hot conductor and the ground conductor in the extension cord. The GFCI is looking at the hot and neutral wires, and if there's 5 milliamps leaking out of the hot conductor into the ground, that will show up in the hot and neutral wires, and the GFCI will trip. If we put our clamp meter around the whole extension cord, it's not going to detect that imbalance because all the current that is leaking to the ground conductor is coming back. We need a way to do what the GFCI does and exclude the ground wire. You can deal with this by taking a short extension cord, carefully cutting off the outer sheathing, and using the clamp-on meter around only the hot and neutral, or black and white wires. That will ignore any current coming back through the ground and behave the same way as a GFCI. If you have a problem cord and you want to make the problem go away, you can use the much maligned 3-prong adapter. Plug your cord into this and then into the GFCI, and any leakage current on the ground will go away. The circuit is still protected by the GFCI, and since you are very likely plugging in light strings that do not have a ground, the extension cord ground isn't buying you anything. At the Garden to Lights display, we have numerous extension cords plugged into other ones, and I have not found that to be a major issue when it comes to leakage, so it's not something I've focused on. We do not use any cord covers, nor do we use grease. Your mileage may vary. For the Garden to Lights display, our biggest issue is metal into the ground. Our plants are mostly made by attaching lights to 1/4-inch steel rod with zip ties. Put that rod in the ground, add some rain or dew, and it's a perfect recipe for leakage. Our main fix has been to put heat shrink tubing on the bottom of the steel rod, the part that goes into the ground. With the number of plants we have, that has taken hundreds of hours to fix, but it has been robust for the last 2 years. New builds use rods that are fully covered with heat shrink. The other metal issue we have is with rebar, which is pounded into the ground to hold up the taller plants. The old design used metal tubing over the rebar, which led to lots of leakage. Now we put heat shrink on the bottom of the plant tubing, we put PVC conduit over the rebar, and then zip tie the plants to the conduit. That has worked well. The second biggest issue is light strings lying on the ground. Our current installation practice says that all connections like this are on elevated stakes, but the problem is what the light strings do after the location where they are plugged in. 90% of my fixes this year were lifting light strings off the ground. That's the real reason I suggest you don't mess with light strings before you do any troubleshooting. I see many cases where just picking up the wire and setting it back down changes the leakage from 4 milliamps down to nothing. I'll also note that many of our plants are 10 or even 20 years old, and light strings just aren't made to last that long. And what if you like lights on the ground? I love them, especially when they're snow covered, but I do have ongoing trip issues. I've noticed that the string of True Tone C9 bulbs that run on the ground the whole way around my yard is pretty much immune to trips, and never shows much leakage when I put a meter on it, so I think the C9 sockets and wires are better at this. I also decided after this year I'm going to stop buying commodity lights, and only buy the high quality commercial ones. It's going to be more expensive, but I'm not only tired of GFCI trips, I'm tired of strings that don't even last a season. Thanks for your attention, and I hope that measuring leakage will reduce your GFCI frustration.